An object has a mode, for example, numeric, character. Our data structures include vector is one-dimensional and with the same type of elements. A matrix is for the two-dimensional objects with same type of elements. An array is similar but can be of any dimensions. And a data frame is a tabular object, and a list is an object that can combine any other type of object. The data frames are the main structures you use to store datasets, and the columns are variables and rows are observations. You can have variables of different types, for example, numeric and a character in the same data frame. So this figure illustrates those basic data structures in R. So this is a vector, one dimension, the matrix for the two dimensions, an array, here is 3 dimensions, and data frame is 2 dimensions, but columns can be of different modes, means the value type, and the lists is an object that can, for example, combine vectors, arrays, data frame, or even lists itself. And many R packages use lists as the form for the calculation outputs. So here we will introduce vector. So elements can be numeric, character, data, or logical. So we create vectors using C function. So this is a numeric vector with 6 elements, and this is a character vector with 3 elements, and this is a vector with true or false called a logical type value. And we can also refer to the vector using brackets. We will show this in RStudio. So we create a vector, numeric vector called A, then we can use a type of A. So the data is stored as a double type. And we create another vector called B with 3 character values. Then type of B is character. We can also create vector C with true or false value. Then next, we can use a function called a sequence, seq, to create length of 5 vectors into Y. Just a note, in R is case sensitive for objects, so lowercase y and uppercase Y are different objects. So this vector has 5 numbers. Now we can use cat function to print something on this screen. We cat, so using sequence function and this vector, then a new line. You can access elements of vector using bracket. So this will show the second elements of this vector. Just also note, in R, index start from 1, not from 0, as in other languages. So the second element is B in this vector. And we can also use a C function for several elements inside the brackets. So the second, fourth, and sixth elements of A are these 3 characters. And we can use a colon operator to calculate, for example, the first to 5th elements of this vector. Then modifying a vector. So first we create a vector with 6 numbers. Then we assign the third element to 1 and the second to 9. Then we print out again these elements. so the elements are modified. And we can also use some conditions to modify the elements. So this statement means x brackets inside the brackets is a condition. So if the elements in x larger than 5, then assign 0 to these elements. So we calculate again, then we print out again this vector. So now x no more than 5 now. And we can also create a new vector based on an existing vector. So here we create a new vector with the same name, but with 3 elements. And C will create a vector with 3, 2, 1. So this vector will be used as the index of this vector x. So the result of x has only 3 elements. So we will show. So now has only 3 elements. And we can delete a vector. For example, we'll create this vector first. Then we can use a value for null, uppercase null to m. Then we print. So this m not exists now. So we can use an alternative way to use RMM to remove these objects. So next we try again. This will show error now because m not found. Little different in the print results, but anyway the m has been removed. Matrix. A matrix in R is a 2-dimensional array in which each element has the same mode, for example numeric, character, or logical type of values. And the matrix are created with the matrix function. So Y is a matrix, and created using matrix 1 to 30, 30 elements arranged by 5 rows and 6 columns. And we can also, for example, set row name and a column name to a matrix when we create a matrix. And we can also access the elements, and for the columns, for the rows. So create matrix to Y, and we print Y, 5 rows, 6 columns. Then we can create a vector called cells with 4 elements. Then create 2 vectors for the row name and the column name. Then next, we can create a matrix using the elements of cells and arranged by 2 rows and 2 columns. And we set an option called by row is true, so the values will be filled by rows, and the default is by column. Then put an argument called dim names user list. Then put in a column name and a row name. Then show this matrix, my matrix, 4 elements for the 2 rows and the 2 columns with column name and a row name. And similarly can create a matrix with same elements and the 2 rows, 2 columns, but this time by row set to false. Show this matrix again. So now elements has arranged by column. First 2 elements you can see by column now. Good. can select matrix elements. X is a matrix. X 4 rows, 5 columns. You see the values have been filled by column by default. Then select the first row of vectors. So this will return a vector because it's a one dimension. And for the third column of this matrix, it's also a vector. Then we can use a bracket, assign two values with a comma separated. This will return a constant value. We can select first row, then two columns, use the C function. Also, two value is a vector. Here we can set a matrix with single value, then filled by 3 row, 3 column. So this is a 3 row by 3 column with all the values equal to 5. And we can create a diagonal matrix having 3 row and 3 column, then filled by an array of elements 5. You can see 5, 3, 3, this value in the diagonal of this matrix. Then other values in the matrix are 0. Create a matrix with 9 elements by row filled. Then print this matrix. And we can show the dimension of this matrix. Is cut for display to the screen. So the dimension is 3 by 3. And we also print the row of this matrix. Row is 3. We can also print the column of this matrix 3. Next, we can print the length of this matrix. The 9 elements total. Can also print the length of this matrix by the production of the dimension. So production the row by column also is the length. Can create a matrix also by row. Print this matrix. Then we can access the first and second column of this matrix. First and second column of this matrix is a smaller matrix dimension. Arrays in R are similar to matrix, but can have more than 2 dimensions. So array is a natural extension of matrix. And they can be used for creating functions that perform statistical calculations. And like a matrix, array must be of a single mode, which means that all elements in an array must be either, for example, numeric or all are character. And they can be created within an array function. So we create, for example, 3 vectors first, with information, character information. Then we create an array with the elements 60 elements from 1 to 60. Then specify a dimension. Then we add the dimension's name using a list with these 3 vectors. So we create 3 character vectors first, then create an array with 60 elements. Then we show this array. You can see there are 3 dimensions, 60 elements stored in 3 dimensions. This is dimension 1. For example, D1 is N1, N1 D1. Then in the biggest block, this is the first block, for example A1, second block, third for 5 block. Then inside 5 blocks, their dimension with 3 by 4 a matrix. So total there are 60 elements in this array, and we can access elements of array use a bracket after the array name, then with the index number. For example, A1, 2, 3 will return an object in the dimension, first dimensions, and inside the first dimension, the second dimensions, number 2, and the third dimension is number 3. So this value is 28. So first dimension here is 1, second dimension is 2, and this is third dimension, 28. And data frame. Data frame is more general than matrix in that different columns can contain different modes of data. So different columns in a data frame can be different types of data, for example, numeric, character, or logical data. So data frames are the most common data structure you will deal with in data analysis in R. A data frame is very similar with, for example, Excel spreadsheet, so tabular data form. So data form is created with the data frame function. For example, can create data frame using data.frame. Then in the parentheses, we put several columns. This is a vector. These are all the vectors. So, for example, these 4 vectors of different types. This is 2 numeric, and these 2 are character. They will create a data frame combining these 4 vectors. So create 4 vectors first, then create a data frame, and we show this data frame. You can see now the data frame has 4 rows. Rows representing observations, so there are 4 observations, and a column represents the variables. There are 4 columns, 4 different value type. A column variables, we also call column variables. So we can identify elements of a data frame using brackets. For example, this will return the first and the second variable of data frame. So pdata 1, 2, 2. The first and the second columns, second column variables. And we can also use the $sign to represent one variable or one column. So the column of age of this data frame are returned. Actually, the result is a vector. We can also return 2 columns using a C function inside the bracket. So 2 columns, blood and the status, these 2 column variables are returned. The returned form is also data frame with 4 observations and 2 columns. str function for data frame, we show the structure of the data frame. So str pdata will show there are 4 observations of 4 variables, and the variable type, column types, numeric, and the fact. character categorical variables. There are two levels, is 3 levels. This is the value, and we can also, for example, return the second variable of all observations. Second variable is age, so the result is all ages, actually the vector. And we can also return all the variables for the first observation. So you can see this will return a data frame, column names, column variables, and this is the value for this observation. And a factor. Nominal categorical variables are factors, for example, gender factors. And all the categorical variables are also factors, for example, bad, normal, excellent, a factor. For this level, a factor level. So categorical, nominal, and all the categorical variables in R are called factors. And the function factor will store the categorical variables as a vector of integers in the range 1 to k, where k is the number of unique values in the nominal variable, and an internal vector of character strings mapped to these integers. So for example, we create two vectors. One is blood with two types, type 5, type 6, a vector. Then we can use a factor to transform this vector into factor type. Actually, this is an unordered factor. And for the status vector, there are three different types of values: poor, improved, excellent. Then we can create or assign status to an factor type vector, and using factor, then inside with a parameter order equals true. So the status will be a factor with ordered factor. So for example, ID, age are two vectors. Then there are two numeric vectors, and we can next create a data frame combining these two numeric vectors and with two factor vectors we created in the previous page. Then a data frame pdata is created. So ID and age, two numeric vectors. Blood and status are two character vectors. Then we set blood to a factor vector and set status to a factor vector also, but with order that is true. Then next we can create a data frame combining these four vectors together. Then next we show the structure of this data frame: 4 observations and 4 variables. 2 columns are numeric, their value, and the blood is a factor with 2 levels, and status is an ordered factor with 3 levels. 3 levels: excellent, less than, improved, and less than. Poor. They are arranged alphabetically. We can use a summary function to the data. So the numeric to show the minimum, first quantile, median, mean value, and third quantile and maximum value. But for the factors columns, should 2 types: fact unique information and the counts of this value. And for the list, a list allows you to gather a variety of possibly unrelated objects under one name. For example, a list may contain a combination of vectors, matrices, data frames, and even other lists. And the results of many complex statistical analysis often return lists. You can create a list using the list function, and where the objects are any of the structures we have seen so far. For example, these are 4 objects. These are character scalar, these are numeric vector, this is a matrix numeric value, 100 value, this is a character vector. So we can create a list combining all this information using list function. Then inside we put A assigned to an object called title, element called title in the list. Then we assign B to an element called sum. So title is a scalar, and the sum is a character vector for B, and the C and the D also put in the list. So we create these 4 vectors in a scalar first, then create a list including these 4 information. Then we show this list. So this list is called the new list, and with a dollars with the element called title, and the information is new list. And the next element called sum, and information is a vector, numeric vector. And the third element in the list has no name, but the information is stored is a matrix, numerical matrix with 100 elements. The fourth element in the list has no name, but the information is stored correctly with a character vector of 3 elements. We can refer to the elements of the list. So for example, this using double brackets to specify elements using number. We can, for example, show the second elements in of this list. And we can also use double brackets to specify the elements using name. For example, sum is a name for the second elements in the list. Similarly, we can use also $sign with a name for name the components. So we show the second component of this list. This list is a vector, the result. Also show the components with the name sum of this list. The result is the same. And show the components of name sum. The result is the same. So we can create a data frame using function read table to read a CSV file or TXT file from the working directory. The format is read table file and with some options. For example, we can set the sep option using comma or tab or as a space. And we can also set, for example, row names and column names for the variable names, and the NA strings if there are some values in the original file not available. We can transform them into not available NA data frame, a string as factors to specify the character variables to convert into a factors or not. So this is a raw part of the original file in a CSV file. The first column is for the variable names, and one row represents 1 observations. Then we can use read table this file, and with a header true because the first row is wanted to be the variable name in the data frame. And we set also row names for the students ID. The first column to be the row names, then using sep comma as separation. We show this in RStudio. First, we set the working directory. Inside the working directory, there's a CSV file. About 20 observations. There are about 10 columns. Then, using read the table to read this CSV file and assign to a data frame called grade. Successful. We show this data frame. And we show the structure of this data frame. 20 observations of 9 variables. Full name, the factor level, because originally the default value would be factor if the character values to be read into data frame. And the race also factor, gender factor. A numerical variable here read as integer variables. Data is also a factor. We can also use the read CSV directly. Just use the read CSV if we want to read the CSV file. And read the CSV, there are 10 variables because the first column is also read into column variables. We can also set a column variable type in read table. So we set a variable type vector first. Then we read this CSV file using read table and an argument called column class and assign with this vector. We show grade. Then we show again str grade. So now the variable type, some of the variable type like character variable type now a character, not as a factor. Sometimes we can use a function called with to simplify your work. For example, this is a normal case without using with. So we want to calculate the summary of this column called mass in the data frame grade. Or we can calculate the correlation between mass and physics. But if we use with function, so we can write with grade, this is a data frame. Then inside the brace, we just write the summary mass and the correlation between mass and physics. So we do not need to write grade data frame first inside with. So we also set a working directory and read this file first. So if we do not use with, just write summary grade with a grade mass. So the statistics of this variable, column variable, has been calculated. You can also create correlation between mass and physics. Minus 0.048. Then next we use grade. then summary math and correlation math and physics. The results are the same. And usually assignments exist only within the function brackets. For example, if we write with grades, then inside the brace, then we calculate a variable called test. Then we show this test within grade. It's okay. But if we want to show this object test after with outside of the with, then it does not work. So inside the with, we calculate summary, then assign to an object called test. Then we also show this object test inside the with block. So that's been shown successfully. Then outside of the with, we show this test, it will show not found. So test only exists within the with block. But we can use special assignment operator, double arrow, to make it possible to assign some value to an object. Then this object is available to use outside of the with block. So we use with grade, then summary, then correlation, then assign summary to the test, use double arrow. Then after the with block, we show this object. It works. Next, we will show some useful functions for objects and mostly for data frame. The length, calculate the number of elements, dim, string, structure we have seen before, class, for the class and the object. We will show all this in RStudio. We set working directory and create data frame grade. Then length grade 10. So the length here, the length will calculate the how many column variables in this data frame. Then we take out the age column variable of grade, then assign to a test. Then we calculate the length of test 20 because each column has one column has 20 observations. So the length of this vector test is a vector has the length 20. Also dim grade dimension, the 20 row 10 columns. str grade we have seen many times. Show all variable names and their type and the value, some values, and how many observations and how many column variables in this data frame. In class, the data frame is class class test, for example, is numeric. The mode stores the value type. So for the data frame, the mode is a list type, and the mode test vector is also numeric. So the names of a data frame, name is the column names, all the column variables name. Then a function C, we can combine elements into a vector. So this is a vector with 20 elements. We can add a 2 with this, then using C function together. So test2 will show 22 now 22 elements in this vector. cbind will combine data frames across columns. So we create a data frame called grade part. The part of the grade data frame which has 3 columns. So these 3 columns actually are the column 7, 8th, and 9th columns of the data frame grade. So we should grade the part as 3 columns: math, physics, and chemistry, name, then we create a new data frame called test3, which column bind. So combination of grade and grade parts by column. So test3 has 20 observations. You see the extra column V1, V2, V3 actually the column name of grade part. So this 3 column has been added with the data frame grade. So test3 now has 13 variables. The last 3 columns are from grade part data frame. And similarly, rbind will combine data frames across columns. So we create another data frame called test4, which has 10 observations, but with all the variables from grade. So test4 has 10 observations, but with all the variables, 10 variables from grade. So next we can rbind, because these 2 data frames has same columns, so we can using rbind to combine them by rows. So test file has 30 observations with 10 variables. So you can use str test file. So 30 observations with 10 variables. Head grade will list the first part, the first 6 observations of this data frame. And similarly, tail grade will show the last 6 observations of this data frame. ls will list the objects in the current working environment. So these are the objects, some are data frames, some are vectors we have created during this working session. We can also delete some objects using rm. For example, we remove test file now. So we show again ls. So test file has been removed. And if we use rm list equals ls, then all objects will be removed. Then we show ls again, there are no objects in this working session. And the sequence function can create a sequential vector. For example, this seq 1 to 10 create a vector from 1 to 10. And we can add a step 2 in the end. So it will create a vector 1, 3, 5, 7, 9. And the rep function will create a repetition of the first value with n, second with n numbers. For example, here the 5 numbers. So this will create a 5 1 in a vector. So the result is a vector with 5 elements. Each is 1. And the cut function will divide a continuous variable x into a vector with n levels. So we create this data frame first. Then we cut age into 3 levels. Now the age variable is a vector with 3 levels, and the value is divided into 3 of the old age from minimum to maximum value. So each level of age here covers the same range. We show grade age. Sorry. You can see the age column of this data frame has been transformed as vector. From 19 to 27, from 27 to 35, from 35 to 43. Basic data management in R. And you can create new variables in data frame. So statements for creating new variables is a new variable and the expression to assign to this new variable. And operators and functions included in the expression portion of the statement, like arithmetic operators, addition, subtraction, multiplication, division. And you can also use exponentiation, use this color or double asterisk. You can also calculate the modulus, means the remainder of a division, use double percent symbol. For example, 10 modulus 3 is 1. And you can also use this double percent with a division symbol, means integer division. So 10 integer divided by 3 is 3. So for example, we will create new variables in the grade data frame, and 2 new variables called total grade and mean grade, which is the sum of math, physics, and chemistry, or the average of these 3. So this is the very normal statement to create new variable. Just a grade, then $sign is a new variable, and we can also use transform to create new variables. So transform this data frame. Then inside the parentheses, you write new variable, and this is existing variable summation. This is a new variable, and this is the average of these 3 variables. So we show this in RStudio. First, set the working directory and reading data. So grade your data frame with 20 observations of 10 variables. For example, math, physics, chemistry are numeric variables. And we create 2 new variables, just using very simple form. So we show this grade data frame again. Now there are 2 new variable called total grade and a mean grade has been created. Show some observations. First 6 observations of this data frame. Student ID, full name, race, gender, physics, math. The last 2 columns called total grade and mean grade in the data frame now. We can also create with transform data frame. Then we do not need to write grade again here. Just use total grade and the mean grade. This also works. Same, the last 2 columns created. We can recode variables in data frame. So recoding means creating new value of a variable conditional on existing values of the same and or other variables. So for example, you may want to change a continuous variable into a set of categories, or replace miscoded values with corrected values to create a pass-fail variable based on a set of cut-off scores. To recode data, you can use one or more as logical operators that return true or false. So these are logical operators. Some are very understandable, but this is for exactly equal to. For the conditional equal to is double equal. This means not equal to. This means not x. So here means x. You have to use x. And here the x or y. Here means x and y. So for example, we will recode the value 999 as NA because in the original CSV file, the missing value has been coded as 39. Then after we have read CSV file into data frame, we can recode the value 999 to NA, means not available, missing value. So we just write grade math, then write a bracket for the condition inside the bracket. So if the grade math value is 99, then this math value will be assigned as NA. So similarly, we assign NA for the physics and chemistry and for data value if their values are 999 in the data frame. So next we can also check is NA have to check if there are NA value in these places. For example, here is means the grades data frames last 4 column has NA value. We create a data frame first. Then we show this data frame. You can see for example, for the date column, the last value is 99. And here for physics, second observation also has a 99 value. So we transform recode 99 to NA for math, physics, chemistry, and date. So now has been shown as 9 NA for these places. Then we can use is NA to test is NA true. Here is true for the last 4 columns. Is NA true here, last 4 columns, second observations true. We can also record the ages of the students in the grade dataset from the continuous variable to a categorical variables, age cat, and there are two levels. So we can set grade age cat, then so grade age cat is a new variable here, and grade age is an old variable in the existing variable in this data frame now. So if the age less than 31, so the value for the age cat will be young, and if the age is larger than 31, the value of the age cat will be middle-aged. And similarly, we can use another method called within. So within will create new variable in the within block. Within, then grade, then is a brace. In the brace, we first assign all the NA to age cat. This is a new variable, so we have to assign all the NA to this first. Then to statement, if age, then the condition is age less than 31 to young. If larger than 31, then the age cat will be middle-aged. We'll show this in Studio. So age cat be created. So now the data frame has been added with a new column called age cat. The value is young, middle-aged. But now this values type is character has not been transformed to factor. So if we want to change it to factor, we have to use as.factor function. We can use another way to use within function. Then within, then a grade data frame, then age cat is NA, age cat's value is young if age less than 31, and age cat's value is middle-aged if age is larger than 31. It will get the same result. Let's say we show this data frame. So the age cat's value is young, middle-aged, young, middle-aged. We can also rename variables. It's quite easy, just use the name function. Name function for a data frame is a bracket to specify which column variable. Then write a new name with a character to this variable. So name grade, we should name grade first. So this is the 11 names for 11 columns of this data frame. For example, we change the 10th name of this data frame to test date. So we should name again. Now, oh sorry, run test date. Then we show this again. Now the 10th column, 10th variable has been renamed to test date. And handling missing values. So in R, missing values are represented by the symbol NA. So we have seen we recode the values of 999 to NA. Then next we can show if some columns has NA value. Then once you have identified missing values, you need to eliminate them in some way before analyzing your data further. The reason is that arithmetic expressions and functions such as contain missing values will yield missing values. So, for example, we calculate the sum of this physics grade. So we have to write na.rm is true inside of this function. So the missing value will be excluded before the calculations. And we can also create a new data frame which omit, remove all missing observations. Remove all the observations with missing values. We create a data frame first, then we recode these values as we have seen before to NA. Then we show is NA value in some columns is true. Then we calculate the sum of physics and add NAIM equals true. So it is possible to get the summation of all the values of physics. Next, we can create a new data frame which removes the observations which has missing values in grade data frame. So the test the data frame. You can see the 10th observation has been removed because there are missing values, and the 20th observations also has been removed. So test data frame has only 17 observations now, and the original data frame has 20 observations. So 3 observations has been removed. Data value. It's typically entered into R as character strings and then translated into data variables such as sorted numerically. The function as.data is used to make this transformation. So for example, the default format for inputting is year, month, day. So we can set a data variable using as.data with C2 dates use the form year, month, date. And we can also use the data using a specified format. We'll show this in RStudio. So test the date created using as.data function with input to string with this format. So we can show now this is to date value. We can read grades. So in this data frame, the date variable is input as this format. So we transform this column date to data format using this specified form, which conforms to the value in this data frame. So we show again. Now the date column data variable in data frame grade has been transformed as data value. And this are formats in the as.data function. For example, this represents number for the month, this for the week, this for the unabbreviated weekday, and so on. We can also show today's date, and this is the calendar date and the time. This date, today's date, then date function, show date and time current. So we assign today's date to today variable. Then we also can output using a specific format for this variable, using, for example, this format. So now format is March 11th, 23. We can also use this format, A, so only output the full weekday. So the arithmetic operations with data value can create two data value, then can minus 1 of 2. Also, we can calculate the interval in different units between two data value. So we create two date using as.data function. So the dates between these two dates is 194 days. We can also output the difference in weeks between these two data value. So about 28 weeks. And also in minutes, about 208,000 minutes. Object type conversion. So R provides a set of functions to identify an object's data type and convert it to a different data type. So automatic type conversion will add a character string, for example, to a numeric vector, will convert all the elements in the vector to character values. And the functions of the form usually is data type. And this is specific data type. Will return true or false. And if you use as.data type, this is specific data type, will convert the argument to that type. So for example, test for a data type is numeric, is character, is a vector, is a matrix, and so on. And convert it to a given type, can use as numeric, as character, as a vector, and so on. So we create data frame first. Then we can test the age column, age variable of this data frame is numeric. Yes, true. And the first name of this data frame is vector. It's also true. Then we can set age variable as character. So now if this is assigned to also to a variable called test, so the age, you can see now the age is not numeric as quotes, so they are character now. And we can also test is numeric for this vector is false. Is vector for test is true. Is character is true. Sorting. So we can sort data frame, for example, from youngest students to oldest students. So can use order function. So test is a new data frame. Then data frame bracket order this variable, then use a comma. So this data frame, so the test data frame is the same value as grades, but sorted by age. Sorted. Also issue. So test is a data frame can sort it by age from youngest to oldest. We can also, for example, sort by gender first, then by age within each gender. So can use order. Then inside order there are two variables, then a comma. So now age is a data frame which start gender from female first. Then for the female, Also, age sorted from younger to older. Then in the male, also age from youngest to oldest for the male. We can also sort, for example, by gender first, then by age, but within each gender, the age is from old to young students. So we add a minus here, minus symbol before age. Then test. So test is the data frame sorted from the grade data frame with gender female first. Then for the female, age from old to young. And the same for the male, age from old to young. So merging and combining datasets. So to merge two datasets horizontally, you can use the merge function. In most cases, two data frames are joined by one or more common key variables, that is an inner join. So for example, we create a data frame with student ID and biology, 2 columns. Then we name this data frame. Then we can merge grades data frame with mdata by student ID because these two data frame has a same common variable called student ID. So we can merge it. Ratio. So biology, create mdata data frame, the name. So mdata is a data frame to have 2 column variable and 20 observations, same as grade. Then we can merge these 2 data frame by student ID and assign to a new data frame called test. So test is a data frame, new data frame, which is based on grade and with extra column called biology, which is from mdata data frame. And we can horizontally concatenation using cbind. If 2 data frames have same number of observations, then we can just want to combine these 2. If they have no common column. So we create another data frame called as.data with 2 columns. So as.data has 2 column variable called biology and English and 20 observations. Then grade and as.data can use cbind to combine together. So this combined data frame has 20 observations and 2 extra columns in addition to the columns from grade. And similarly, we can combine data by rows if 2 data frames have same column variables. We create a smaller data frame from grade called rdata. So rdata has only 5 observations, but with same column variables as in data frame grade. So these 2 data frames can be used with rbind function. So now the resulting data frame has 25 observations. with the same column variables as in grade data frame. Subsetting datasets lets you to create a new dataset from a limited number of variables chosen from a large dataset. So for example, we can select grade scores for math, physics, chemistry. We just use C for these columns. Similarly, we can also use C, the names for these columns. So we just use test is grades, comma first. Then for the column, we select these 3 columns. Issue. So test has only 3 columns. They are math, physics, and chemistry, and 20 observations. We can also use grades, then see their variable names from grade. So the result is the same. Test is a data frame of 3 column variables. So if we only use a number in the bracket of the data frame, then it will select a column. So with 8 is a physics. The result is also a data frame. We can drop some variables from data frame. So first, we'll create a variable called vars. This is the logical value. This means names grade. Names grade as 10 column, 10 names is in these 2 names. We will show the. You can see this is a logical vector. So this 2 is true, others are false. So next we can select only not true in dvars columns. So the result for the test is 8 columns, because 2 columns is true with this conditional test. The result is 20 observations with 8 column variables, which math and chemistry not included. Similarly, we can create this data frame with a C, then inside the parentheses -7 and -9. Then these 2 columns are not included in the resulting data frame. So you can see math and chemistry not included. And we can also, if we want to remove some columns of data frame, we can set null to this variable, this column name. So we should also grades data frame has no, math has no, by chemistry now. If we want to select observation, we can choose observations number before the comma in the bracket. So this will select observations 3 to 6 of this data frame. So the resulting test data frame has 4 observations with odd columns from grade. Remember, grade now has only 8 columns now. And we can also, for example, select male students and younger than 25-year-old. And we can grade bracket, inside the bracket, before the comma, grade's gender is male and grade's age younger than 25. Show test. So now only 3 observations in the resulting data frame. So male student and age younger than 25. And you can select, for example, grades tested from 2008 October to 2009 March. We first have to set grades to data as data value. Then we create start date and end date as to data value. Then the result will use which the inside the which is true condition for the data value. So now only about 8 observations with test date between these two values. And we can also use subset function. Subset grade, then gender, for example, is male and age that's younger than 25. Then select math and chemistry. If there are lots of selection conditions. Sorry, chemistry not found. Create data frame first. Then so now data frame has 3 observations for male and younger than 25. Then for the column, we only select 2 columns, math and chemistry. So this data frame has 3 observations, 2 columns. Mathematical functions. Some common mathematical functions, and most of them can work on both scalar, vector, matrix, and data frames. So for example, this is an absolute value and square root seeding. We will show all this in RStudio. First, create dataset. The grade dataset has 20 observations with 10 variables. We will use it later. So mathematical functions, for example, absolute value, get 5, square root for vector, get 5 for same dimension and this vector, seeding, we get 6, the floor, we get -3, and the truncate, we get -3. Round to digital 2, then log, and exponential. And for the statistical functions, most of them can also work on both scalar, vector, matrix, and data frames. So mean, median, standard deviation, variance, and quantile. So x is a sequence number, vector 100 number, then the mean average of this vector, the standard deviation of this vector, then the variance. And we can also calculate the trimmed mean, dropping the highest and the lowest, for example 5% the scores. So this trim equals 0.05. We should say is about 50.5. The scale function is standardized vector with mean 0 and standard deviation 1. So this is a scale means standardization of a vector. So you can see the 100 value has been standardized with means 0 and standard deviation 1. Minimum and the maximum. And the range, the minimum and the maximum value, and the difference. So each value is the difference between two neighbor values in original dataset. So there are about 99 values now for the difference. The quantile, so the value, about 70% of the value and this value. So 70% of the observations and this number 70.3. So under 70.3, there are about 70% of observations in this data set. So we see the probability functions. So in R, probability functions take the form one of the alphabet in DPQR. Then is a distribution abbreviation. D means density, P means distribution function, and Q means quantile function, R means random number generation. And for the probability distribution abbreviation, this is binomial, the logistic multinomial, for example, negative binomial, chi-square normal, and so on. So we will show we generate and plot normal distributions variables. So first, create a variable, a vector called x about 31 numbers. Then we can calculate y is the density function, density value of normal distribution of x. So we can also show y. This one. We also create a dataset, data frame, using these two vectors. Then the P can calculate the area under the standard normal curve to the left of say equals 1.25. So the area is about 0.89. And we can also calculate the value of the 60% percentile of a normal distribution with a mean of 30 and a standard deviation of 8. With Q norm 0.6 and mean is 30, SD is 8, about 32. We can also generate 20 random normal deviates with a mean of 30 and a standard deviation of 8. So R norm here, 20 mean and a standard deviation. So these 20 random numbers. Next, we can using set seed to make your results reproducible. So for example, this is random number generates for the uniform distribution, 10 number between 0 and 1. Then we calculate again, not the same as the last one, but if we set a seed, for example, to 5, 6, 7, 8, then we run this command, and we set a seed again with the same seed. Then we run again this command to get the same result. You see the last run has the same results. So for the character functions are used to extract information from textual data or reformat textual data. So for example, to upper, we get uppercase of this string, and to lower, we will get a lowercase of this string. To up this string, so all is uppercase now, and to lower, the old string is lowercase now. NCHAR will count the number of characters of y. Y is a string, so char r is interesting. So you get 13 or 16 strings. Then paste will concatenate strings after using specific sep string. So for example, paste y and paste y with 5 to 7. Then we use the empty string as the character as the sep. Then you will get a vector with 3 characters. y5, y6, y7. Then sub.str will extract substrings in a character vector. So this is the start position and this is stopped position. So we'll substring from this string, start from second value and stop at fourth value. So we'll get these 3 string. And a sub will replacement for this pattern. So if the fixed is false, then pattern is a regular expression, and if it is true, then pattern is a text string. So we sub this is if we default is using regular expression. So this is for the space. Then space is replaced with a dot for this string. So you can see the result is R is easy. But this is only for the first occurrence of the space. Is replaced with a dot. Then we use fixed is true. So this is a string, not regular expression. So this one will be replaced with not. We show to display the R not easy now. So R is easy. Now it's transformed to R not easy. And the grep will find the search patterns in X and return the matching index. Similarly, if the fixed is false, the pattern is a regular expression. If it is true, then the pattern is a text string. So we grep this is character from this vector. Then it will return the index of this vector 1, 2, 3. These 3 elements has R alphabet. And str split will split the string, and if fixed is false, then pattern is a regular expression. If it is true, pattern is a text string. So we split this one and using empty character as a sep. So it will be split with 4 alphabet elements. And for the apply functions, the apply function can be used to apply functions to any dimension of an object. So the form is apply an object, then with the margin and a function, where x is the data object, margin is the dimension index. Function is a function you specify in a matrix or data frame. So if the margin is 1, so indicates rows, and the margin is 2 indicates columns. So for example, test is a matrix created with a random number normally distributed with 4 rows, 5 columns, and we can apply for the row for the mean, so that we return a mean value of each row. Then similarly, we can calculate the column mean of each column. Then we can also use the trim the column mean. So test is a matrix, 4 rows, 5 columns. Then apply a function mean to the rows. You'll get a vector with 4 elements. 4 elements is the mean value for each row of this data frame. And we can also calculate the mean value for each column. So the result is the 5 elements in a vector. Each represent the mean value of each data frame column. And we can also trim 0 to 2%, 0 to 20% for each end of the columns. So the result is the same as last one. Control flow in R lets you execute some statements repetitively, or execute other statements only if certain conditions are met. So looping is a type of control flow, and constructs repetitively execute a statement or series of statements until a condition isn't true. So we can write a for loop will execute a statement repetitively for each value in the vector sequence. For example, a for loop for I in I to 1, 2, 3 will print I love R. So the sentence I love R will be printed 3 times. We will see in RStudio. So for I in 1, 2, 3, print I love R. And a while loop. While loop will let you execute a statement repetitively until the condition is no longer true. So for example, we set 5 to variable I, then can write a while loop. So if I is larger than 0, then we print this statement. Then inside the brace, this is a while loop block. Next statement after printing is minus I with 1, then assign to I. So I will be less and less. So if I larger than 0 is not met, this condition is not met, then the while block loop will be stopped. Set I equals 5. The while loop will print I love R if I is larger than 0. So 5 times of this sentence have been printed out. And the conditional execution. So if else is a control structure for executing a statement if a given condition is true. And a different statement is executed if the condition is false. So this is if else. For example, we can transform variable race as a fact if its element is character. Then the statement is if. Then inside the parenthesis is a conditional test is character. So if data frame grades race variable column is character type, then we transform this variable as a factor variable, and transform grade variable to a factor if it is not. So we can also write, for example, if grade is not a factor, here is exclamation symbol in front of is a factor, which is the negative of this condition. So if grade is not factor, then we will transform it to factor. Otherwise, which means is a factor. If it is a factor, then we just print grade already is a factor. So we first read in data, then we do some management to transform the data as we want. So you can see the grade data frame has a score grade column and first name, last name, student ID, race, gender. Then show each variable. Race is a character now, gender also character. Score numeric, grade also character. Next, we will run. So if race is a character, then race will be transformed to a factor. So we show again. Now the race has been transformed to factor type. We also do this to grade variable. So if grade is not factor, then transform to factor. Otherwise, we just print out statement. Not print out, then we show grade is a factor now. And another compact conditional test is if-else. Write together if-else. So if a condition, then two statements in parentheses. These are compact version of if-else construct. So the first statement is executed if the condition is true, and the second statement is executed if the condition is false. For example, we can print differently according to if the score is greater or less than 0.5. So we can write if else grade score is larger than 0.5. If it is true, then print you have passed the exam. If not, then print you have failed the exam. So print, run this statement. So we can see that's really one because we have transformed the same score will have same index. So some students got the information you have passed the exam, and many got information also you have failed the exam. And the switch is also a control flow with expression. So choose statements based on the value of an expression. So where the statements are tied to the possible outcome values of expression, then print differently for different country. For example, we set a vector called country with two elements, USA and Germany, inside this vector. Then we can write a for loop for I in countries. Country is this vector. Then inside the for loop, brace for loop, then we can print. The inside the print parenthesis is a switch function. So switch I This I is the country, each country. Then switch I, then we can match. If I equals one of these values, then we print. Then this message on the right side will be printed out. So we will show this. First, assign two countries to countries. Then a for loop to print out. But which message will be printed out will depend on the value in the country. If it matches one of these four country preset in this switch statement. So because there are two countries, US and Germany, in the countries. So two messages, I'm in North America, then I'm in Europe, are printed out. Create your own functions in R. In R, the function structure is use a function keyword, then is the argument, then is the brace. Inside the function argument is a brace, then can write a statement, and usually can return object. So this function, usually we call this function and return the value to this object. So where the object in the function are local to the function. So this object, for example, are local. So we have to return this to the object outside of the function. And the object returned can be of any data type from Scala to list. So for example, we can create a function for printing summary statistics. So sum is a function we created, then use function state keywords, then in the argument there x, and we set two arguments has default value. One is par is true and print argument is false. So if in the functions inside the function block we write if par, which means if par is true, then this block will be run. So the CN variable will be the mean of x, and SPR will be the standard deviation of x. But if par is not true, then we will calculate SCN will be the median of x, and SPR will be the MET. MET is the median of the absolute deviation from median. So else. So we use if else conditional test in this function. Then next is another if else block. So if print and par, so if both are true, then we will cat will print something on the screen. We'll cat mean is the value, mean is mean, and SPR. So we'll print out the mean and the standard deviation on the as printing window. If else, if this not met, but this met. So if print is true and is not true, then we will catch median and MET value on the screen. Then the result will be a list type object will be created to result with the center is sen spread SPR. Then we return this result. So we call the function we can, for example, some function x is a 500 random number, normally distributed. Then we can call this function, and we can call this function use some argument printing is true because print default is false. So we create this function first. Then we set a seed. Then x is random number, 100 random number. Then y is, then call this function with x is parsing x, then show y. Now the mean is this center value is minus 0.16 and the spread is 1. Because spread is because this normally distribution random numbers is standard normal with mean 0 and standard deviation 1. So this is very close to this parameter. And we can also call this function with x, but print is true now. So this will be printed out directly on the screen. We can transpose a data object using t function. So for example, test is a data frame from grade with 5 observations and variables, 3 variables. Five observations, 3 variables, age, math, and physics. So we can transpose this data frame now. Now these 3 variables has been transformed to 3 rows, and this has been transformed to columns. Aggregating data, you can produce summary statistics based on group of observations. So general format for aggregating is aggregate data object, then by, then function. So x is the data object, by is the list of variables that will be used to form group of observations in x, and function is aggregation function. So for example, we want to calculate the mean grades for student groups by gender and country. So we can first, for example, this is a test object with these columns and all the observations from grade. Then test the gender and the country we set as factor variable because in the aggregate function list, by is a list, and in the list have to be factor variables. Then we can use aggregate test, then by this gender and country, then the function is a mean, and we remove missing value. So we create a dataset first, then test. So test the data frame with 20 observations and 5 variables. Then we transform these two gender and the country as factor variable. Then we can calculate them as by the gender and the country of the mean value of the scores. But the warning message will show now AGG can see the group. There are 4 groups: female, male, and with the 2 countries. And for the gender, country also included in the resulting aggregate, the NA, because they are not possible to calculate the mean value for these 2 variables. And other 3 columns has been calculated with the mean value. A better solution is not include these 2 in the resulting data frame. So we can use another form using aggregate test, then exclude these 2 columns in the test data frame. I'll show again. So now is better. Very clear. The first 2 columns is used for the group female UK. Then the next 3 columns are the results for the grades. And we can also see a function descriptive statistics. For example, these three are called variable, they are vector. Then we can select these three vectors, then using a summary function. Then we can calculate the summary statistics of these three subjects. So the math, physics, chemistry, the minimum, and the first quantile median, mean value, third quantile, and maximum value. Plot2 package for graphs in R. The ggplot2 packages use a series of functions to build up a graph in layers. So first, we have to install packages ggplot2 here. Then we load ggplot2. In this video, we will first set the working directory. Then we build a dataset, a virtual dataset called income. So this dataset is a data frame with 300 observations of 9 variables with salary level, education race, and we will use job, years of appearance, age, these variables. So first we load the ggplot2. Then the first function in building a graph in the ggplot2 package is to use the ggplot function. So this is the main function, and it specifies the following: the data frame containing the data to be plotted, then the mapping of the variables to visual properties of the graph. The mappings are placed in an AES function. So this is a basic operation of a ggplot2 function. So with the ggplot, then a dataset, usually a data frame, then with the mapping specifies the variable. For example, here the year is for the x-axis variable, salary is for the y-axis in the graphs. So we set up ggplot2 function, dataset income, and mapping between the variable years and variable salary. But you can see the graph is empty of contents. So next we have to add geoms in plot, because geoms add geometric objects like points, lines, bars, and shaded regions that can be placed on our ggplot2 graph, and they are added using functions whose names begin with geom underscore. Some common and frequently used geoms are, for example, geom bar for the bar chart, and geom box plot for the box plot, and density plot, and histogram. And there are lots: geom line, point, smooth, text. So we add a sketch plot of years and salary using geom point and plus sign after ggplot2 functions. So the functions are chained together to build a final plot. So we add a geom point here after the ggplot2 function. So ggplot, then add a geom point. So this is a very basic sketch plot between years and salary level. We can also set some optional point for point color, transparency, and size. So here we set inside the geom point, we set the color and alpha level for the transparency and the size. Then we add a seam. Seam we'll talk later. So now the graph is more beautiful with the color for the points and the transparency and the size have been set. Then we can also add a fit the line. After GM point, there are seam, then plus a GM smooth line with a linear regression, linear line. So you can see this line is a linear and with confidence interval for the shaded region. Then next we can show the grouping parameter. We can use for different observations in different group, then can be printed differently in a single graph. And the group variables is usually categorical. So for example, here we use different point, shape, color, and line type for male and female observations. So inside ggplot2 main function, we add mapping is AES, then mapping is AES, then inside also add a color with gender, shape also gender, so line type gender, then so the color, so the graphs will be plotted differently for different gender. And the later are the same as in the previous figure. We add a GM grouping. So now for the female and the male observations, that has been plotted in different groups with different color, shape, and the line. We can also use scales. Scale functions allow you to modify default scaling such as tick marks and tick mark labels and axis labels, and can specify the color used to represent the labels of categorical variable. So we add two more functions for the scale x, which defines the range and the step, and for the scale y, continuous also for the range and the step. Then we add a scale color menu for the scales color differently. So scale X continuous and Y continuous and scale color menu. So now the range has been plotted with a specific definition in the scale X and Y continuous, and the colors also a little more different. We can also add a $sign here for the Y axis, but we have to install the package scales first, then load this package before we using the $sign. So first we load the scales library, then inside the Y continuous add a label equals scale $. So now the labels for the Y-axis has been added with a $symbol. Then next we can use facets. So facets let you place groups in side-by-side graphs. This is different from the previous graphs because we have seen all the graphs plotted in one graph. So now facets let you place groups in different graphs. So facet rep, for example, place plots into n columns, and this is for n rows, and this is for combinations of rows and columns, and this can plot into a single column and for single row, for example. So we add a facet rep for the job. So different job, people with different job occupation will be plotted in different graphs. So now different occupations like doctor, driver, engineer, sales, teachers have been plotted in separate graphs. And we can also formulate labels. The label function lets you format labels for axes and legends, titles, subtitles, and captions. So we add labels function here with the title, subtitle, and captions. So this is the title, this is subtitle, these are the captions have been added. Then we can also formulate themes. Themes can be used to formulate the appearance of a graph, and a theme combine background colors, fonts, grid lines, legend placements, and other non-data related features. We can change another theme called theme minimal, which produces a white background and a light gray reference lines. So the themes have been changed. And for the ggplot2 graphs, and the graphs can also be saved as objects, and you can use it later and manipulate it further by step, plot it or save it to disk. So we can create ggplot2 object called plot1, then we can plot this one, and we can add some geom smooth line, for example, later. So step 1, we create this object, then we plot, then we add geom smooth and ellipse upon this plot, then assign to a new object called plot2. Next we can plot this plot2. So with a smooth line added. We can also save graph, use ggsave to the working directory with these files, and the object plot2 saved to this file with the width and height. So this is the saved objects with a PNG file. A bar chart displays the distribution of a categorical variable through vertical or horizontal bars. So in ggplot2, we can use ggplot and dataset, then add a categorical variable into X, then we use gun bar function. So we first load ggplot2, and we set working directory and option. Here we load the dataset called grade. There are about 20 observations with 10 variables, with the students' grades for math, physics, and chemistry. Then we can show the frequency of the gender using GOM bar, then add title and labels for X and Y. So there are about 11 for the female and 9 for the male student. And you can also to add a function called coordinate flip to change the bar chart to horizontally plotted. So we add coordinate flip here. So the same data for the gender has been plotted in the bar horizontally. And stacked or grouped or filled bar charts. So stacked bar chart will plot each segment represents the frequency or proportion of, for example, country within a given gender. So we use the ggplot, then X is gender, for example, then fill with a country, then the bar will be stacked. So stack the bar chart for the gender, but stacked by country. This is for the UK, is red color, the green for the US country, and for each gender. And the grouped bar chart means segments of, for example, countries sit side by side within each gender. So in the GOM bar, you can add a position dodge. Then in AES, the same to use fill is a country. And we'll see grouped bar chart, fill country here, then position dodge. So now for each gender, 2 countries has been sitting side by side. And you can also use a filled bar chart. So a stacked bar chart rescaled so that the height of each bar is 1. So the segment heights represent the proportions of each group. So here the AES is same, use gender is X, fill is a country. Then in the GOM bar, we set fill to the argument position. So filled bar chart. So now the height for each gender is the same, equals to 1. Then each country, for example, for the female students, represents the height represents the proportion for each country's students within each gender. Histograms display the distribution of a continuous variable by dividing the range of scores, for example, into a specified number of bins on the x-axis and displaying the frequency of scores in each bin on the y-axis. So in ggplot, we first load ggplot2 and scales. Then, for example, a simple histograms can be displayed for the distribution of physics scores. So we also use the data grade, then X is physics, then just add GUM histograms. See a simple histogram for physics scores. So you can see this is for the frequency counts, how many people for each score between 60 to 100. Now we can also use colored histogram for the physics scores. So here the same grade AES, X is physics. Then in the GUM histogram, we add bin is 5, then color is white, then fill is still blue. So now the colored histogram with 5 bins between about around 60 to 100. Data has been divided into 5 bins with equal width. Then the height represents the scores for each bins. And we can also plot histogram plot with percentages. So here we add the Y as density. Then in GUM histograms, same as before with the bin, but we add the bin as 30. Then white as color, for fill is scale blue. Then we add scale Y continuous with the label. We add scales double column for the percent. Just remember we have loaded the package for scales. So double column for percent. So histograms with percentages.